I'm Alec Young with SMTA TV. Today I have Chris from Indium with me. How are you doing today, Chris?
Great.
Good. Welcome to SMTA International 2019. It's nice to have you here. We spoke a little bit. We were talking about low temperature soldering, kind of what Indium has done, the different trends you guys are seeing. Would you care to elaborate on that and let us know what Indium's focus is?
Well, yeah, and maybe to start off, I'll give a little background about what's happening in the industry. The driver for low temp, there are several of them. Probably the biggest driver is that some packages, when you reflow at normal SMT temperatures, let's say 240, 245, you'll see warpage, a lot of warpage in them, and that could cause defects in soldering. So one novel way to approach that is to go low temperature. You don't see the high temps, you don't get the high warpage. So, and there are other benefits that you could potentially get from it too. But so those are there's several drivers for low temp. And the solution is, the nice thing about low temp, there was a great alloy. It was bismuth tin and bismuth tin silver. And they gave just the temperature range everybody wanted. You wanted to reflow around 180, something like that, 185. And it was low cost, abundant. So it was great. Everyone said, this is wonderful, right?
Definitely. Yeah.
What's wrong with that?
Yeah.
Guess what?
There's something wrong.
There's
something definitely wrong with that.
And unfortunately, bismuth is brittle.
Yes.
And, you could reduce the amount of bismuth, but you're still, when you have high levels of bismuth, you're very brittle. I think we were talking earlier, and, you could actually take a circuit board that's made, and you could be in PCB assembly, it could be an operator, and they could just twist it a little bit, and the components will actually crack, the solder joint. So that's a real problem. And then if you use it in application, a lot of applications, electronics just kind of sit there, but they actually have to make it there without being dropped. So a lot of end users are really apprehensive about implementing low temp because it does put the reliability of the product under great pressure. And in these days where people are looking for better reliability, it's kind of hard to take a big step back and sacrifice a lot of the drop shock and the fracture toughness properties of the product.
So taking a step back and looking at the greater picture with low temp soldering, how is Indium combating that problem? What solutions do you guys bring to the table to solve some of those issues?
Yeah, we're a material science company, and we have really bright scientists there that love to come up with new material stuff. So they were challenged to come up with a new solution, something that would give you low temp properties but have really comparable drop shock or toughness, fracture toughness properties to SAC 305, and also great thermal cycling properties also. So they kind of scratched their heads, they worked at this for a long time. They kind of exhausted all the tin bismuth alloys. They tried reducing the bismuth, tried various dopants, and you can get incremental improvements, but I can tell you, if you look at the graphs, they're horrible.
Yeah.
So nothing works well. So they kind of started over from scratch, and they said, hey, we have some experience with mixed powders where we have, powder A and powder B. They're different alloys. So they took that technology and they evolved it for this system that we wanted, and they came up something that we can reflow in the range. We're still trying to fine tune exactly the process window, but we can reflow it at 200 to 210 centigrade versus, like I said, 240 to 250 centigrade for the standard SAC 305. So that buys us a lot of temperature. That's a lot less stress on components, a lot less stress on the board, and basically it reduces warpage quite a bit. So although the goal in the industry was to get below 190, we weren't able to get below 190, but we're pretty close at 200 to 210. So this is a brand new product that we're introducing, and we'll see, how it does in the marketplace. But I can tell you, as someone who really kind of appreciates novel material science, this is really a cool technology. So we look forward to it. We're introducing it here, and we call it DuraFuse LT. And it's a mixture of different alloy powders. And the unique thing about it is when you reflow it the first time, you will get some low melt point phases, because there are some very low melt point phases. And then you'll get more phases melting over time in the reflow. And then finally, when you're at 200 or 210 for your peak reflow and you hold it there a while, you have a lot of melting going on and diffusion, and you get kind of a homogeneous solution that's on the, if you're into phase diagrams, you're on the tin-rich side of the tin indium phase diagram, and you don't have any low melt point phases left. So when you come back to reflow this a second time, there's no low melt point phase. So you're left with nothing, and actually the melting is now higher. So it's very unique, and it is really cool technology that's patented. So we're just starting now. This is the initial entree into the market, and we have had a couple customers testing it with really good results, and we hope that it brings value to a lot more.
Yeah, well, it's great to hear that it's in the market, it's out there ready to be used, so it's all super interesting. Chris, thanks again for your time coming on SMTA TV. Appreciate it, and have a great rest of your show.
My pleasure. Thanks.
Thank you.